They knew. That's the part most people never hear about. Before the fireball, before the shock, before millions of eyes watched something go terribly wrong, there was a room, a conversation, a hesitation, and then a decision. On the morning of the 28th of January, 1986, the world wasn't expecting tragedy. It was expecting inspiration, a routine mission, another successful launch, another step forward in humanity's journey into space. But this story doesn't begin that morning. It begins years earlier, with a flaw no one fully fixed. The mission was called STS-51L. Its purpose was straightforward: deploy a satellite, conduct scientific experiments, and continue proving that spaceflight had become almost ordinary. But there was something different this time. For the first time in history, a civilian was going to space. Christa McAuliffe, a teacher, a woman chosen from thousands to represent something bigger than science, something human. She wasn't just part of the crew, she was a symbol of possibility, of education, of a future where space wasn't just for astronauts, but for everyone. Classrooms across the United States prepared to watch her lessons from orbit. Millions of people tuned in, not out of fear or curiosity, but pride. Because by then, the space shuttle program had built a reputation. Reliable, routine, safe. At least, that's what everyone believed. But beneath that confidence, there was a problem. A quiet one. Ignored, repeated, documented, and dismissed. The space shuttle relied on two massive solid rocket boosters, SRBs, to lift it off the ground. These boosters were built in segments, and where those segments connected, they were sealed by rubber rings known as O-rings. Simple components, but critical, because if those seals failed, hot gases could escape. And if that happened, the result wouldn't be minor damage. It would be total destruction. And here's the part that matters. Those O-rings had already shown signs of failure before. In previous missions, engineers had observed erosion, damage, evidence that the seals weren't always holding perfectly. They knew it, they documented it, they talked about it, but nothing catastrophic had happened yet, so the risk slowly became normalized. Each successful launch reinforced a dangerous belief that the system was more resilient than it really was. But there was one condition that made the problem worse. Cold, very cold. On the night before the launch, temperatures dropped dramatically. Ice formed on the launch pad, the kind of cold that changes how materials behave. And rubber, especially the kind used in O-rings, loses its flexibility in low temperatures. Instead of sealing tightly, it becomes stiff, slow to respond, slow to seal. And that delay, just a fraction of a second, could be enough to let superheated gases escape. Some engineers understood exactly what that meant. And that's where the story truly turns. Because on the night before the launch, there was a meeting. A call between NASA and the engineers at Morton Thiokol, the company responsible for the boosters. The engineers were concerned, deeply concerned. They had data, they had observations, they had a growing sense that launching in those conditions was dangerous. So they made a recommendation. Do not launch. Not tomorrow, not in this cold, not under these conditions. It wasn't a vague warning, it was a clear position. But then something shifted. NASA didn't just ask for their opinion, they asked for proof, definitive proof. They wanted certainty that failure would occur. And that's where the logic changed, because engineering doesn't work like that. You don't always get certainty. You get risk, probability, patterns, warnings, but not guarantees. The burden of proof quietly flipped. It was no longer about proving the launch was safe. It became about proving it was unsafe. And that's a much harder thing to do. The engineers hesitated. The data wasn't perfect. The evidence wasn't absolute. And under pressure, the recommendation changed. The launch was approved, even with the warnings, even with the history, even with the cold. And just like that, the most important decision in this entire story was made. Hours later, the world watched. The sky was clear. The air was freezing. Ice still clung to the structure of the shuttle. But the countdown continued. 10, 9, 8. Everything looked normal. 7, 6. Nothing seemed wrong. 5, 4. Millions of people leaned closer to their screens. 3, 2, 1. Liftoff. The engines ignited. The boosters roared. The shuttle rose into the sky, trailing fire and smoke. For a moment, everything felt exactly as expected. Routine, predictable, safe. 36 seconds into the flight, something began to happen. Not visible to the public, not obvious to the untrained eye, but something was wrong. Inside one of the boosters, the O-ring had failed to seal properly. A tiny gap, a brief delay, but enough. Hot gases began escaping. At first, it was subtle, a flicker, a disturbance. Then, At 59 seconds, a visible flame appeared, a thin jet of fire shooting from the side of the booster. Still, the shuttle continued climbing. 73 seconds after liftoff, everything changed. The flame reached the external fuel tank. The structure couldn't withstand it, and in an instant, the shuttle was gone. Not an explosion in the traditional sense, but a violent disintegration. A breakup at incredible speed. Fire, smoke, fragments, spreading across the sky. On the ground, there was confusion, silence. People didn't immediately understand what they were seeing. It didn't look like a typical explosion, but deep down, something felt wrong, very wrong. The shuttle was no longer ascending. There was no recovery, no control, no chance. Debris fell into the ocean for over an hour. And inside that chaos, the crew cabin separated. For a brief moment, it remained intact, rising, then falling. There is evidence that the crew may have survived the initial breakup, that they experienced those final moments. But eventually, the descent ended the only way it could. With impact, the world watched, and then the realization hit. This wasn't a malfunction. This wasn't random. This wasn't unavoidable. This had been building for years. In the days that followed, the shock turned into questions. And those questions led to an investigation. The Rogers Commission, what they found wasn't just a technical failure. It was something deeper. Yes, the O-ring failed. Yes, the cold temperature played a role. Yes, the design had weaknesses. But those weren't the only causes, because the real failure was human. Warnings had been ignored. Concerns had been dismissed. Communication had broken down. Engineers had spoken, but not loudly enough to stop the machine. And management had listened, but not enough to act. There was pressure to maintain schedule, pressure to meet expectations, pressure to prove that the system worked. And over time, that pressure created a culture where risk was redefined, not eliminated, not reduced, just accepted, normalized, until it no longer felt like risk at all. The investigation revealed something chilling. This disaster didn't start at launch. It started the night before. In a room, during a conversation, when doubt was present but overridden, the consequences were immediate. The space shuttle program was suspended. Years of redesign followed. The boosters were rebuilt, the O-rings were improved, safety protocols were re-examined, but the deeper change was cultural. A recognition that success doesn't mean safety, that repetition doesn't mean reliability, and that silence can be deadly. Because in the end, this wasn't just about engineering. It was about decision-making, about how organizations handle uncertainty, about what happens when warnings are inconvenient. And maybe that's why this story still matters today, because it's not really about a shuttle, or a launch, or even an explosion. It's about something much more familiar. A moment where someone knew, a moment where someone hesitated, and a moment where, despite everything, they moved forward anyway. So the next time you hear about the Challenger, remember this. This wasn't a technical failure. It was a decision. The system didn't fail. The decision-making did. They didn't ignore the risk. They redefined it. And the disaster? It didn't begin in the sky. It began the night before, and they launched anyway. If this story made you see things differently, take a moment to reflect on how many decisions in the world around us follow the same pattern. And if you want more stories like this, stories that go beyond what happened and explore why, make sure to stay here. Because sometimes the most important part of a tragedy happens long before the moment. Everyone remembers. And by then, it's already too late.